Hey everyone, imagine telling an AI a simple instruction and watching it turn that into a multi-step plan, learn from outcomes, and get better over time, all on its own. In the next 7 minutes, I'll show you exactly how Agentic AI does that, how prompts become goals, and the practical techniques used for self-improvement. Stick around for a lifestyle demo and safety checklist. I make technical, practical videos about building and evaluating advanced AI systems. If you want clear explanations, demos, and tools you can try, hit subscribe and ring the bell. All right, let's unpack the idea of Agentic AI. Here's the roadmap. First, we'll define Agentic AI and how prompts map to explicit goals. Then, we'll examine the core mechanisms for self-improvement. Things like online fine-tuning, reinforcement learning, self-play, and meta-learning. I'll walk you through common architectures, show a short demo example of a prompt turned into an iterative agent loop, and finish with safety, evaluation metrics, and resources. First, what is Agentic AI? In practical terms, an agentic system is one that perceives instructions, prompts, generates explicit goals or subgoals, plans actions, executes them in an environment or via tools, observes outcomes, and updates itself. Key difference from stateless LLM responses is persistence. It retains or updates strategy over time and pursues longer horizon objectives. So, how do prompts become goals? There are 3 common steps. Number 1, intent extraction. Parse the prompt to infer the user's explicit and implicit objectives. Number 2, goal formalization. Convert intent into measurable goals and success criteria. Number 3, decomposition. Break goals into subgoals and tasks with priorities and dependencies. I'll show examples in a second. Example time. Prompt: grow my newsletter to 10K subscribers in 6 months. Intent extraction yields: grow audience. Goal formalization becomes: target equals 10,000 subscribers. Time frame equals 6 months. KPIs equals weekly signups, conversion rate, churn. Decomposition yields tasks: content calendar, paid ads experiment, referral program, analytics pipeline. That structured goal is what an agent pursues iteratively. Okay, once goals are defined, how does the agent self-improve? There are several mechanisms I want you to know: online fine-tuning on collected data, reward modeling and reinforcement learning, self-play and simulation, meta-learning for faster adaptation, and automated prompt or policy optimization. Each has trade-offs in sample efficiency, compute cost, and safety. Quick deep dive. Fine-tuning updates model weights using collected interaction data. Great for specialized behavior but can overfit or drift. Reinforcement learning optimizes a policy against a reward function. Powerful for sequential decisions, but needs careful reward design. Self-play uses agents competing, cooperating with themselves to create curricula, famously used in AlphaGo. Combine these with off-policy replay buffers and safe exploration strategies for robust learning. Architecture patterns. How these pieces are wired together matter a lot. Common patterns. 1. Planner-executor. A planner generates a sequence of steps, and an executor runs them. 2. Hierarchical RL. High-level policy picks subgoals, low-level policies execute. 3. Hybrid LLM plus tools. An LLM decides actions and calls specialized tool APIs. 4. Continuous learning pipelines. Modules for data collection, offline evaluation, and scheduled or triggered updates. Pick patterns based on task structure and safety needs. Now for a short demo walkthrough. Not live code, but a reproducible design you can build. I'll describe an agent that iteratively optimizes blog SEO to increase traffic. Step 1. Prompt to set goal. Increase organic traffic X%. Step 2. Agent scrapes current keywords, generates content ideas, publishes drafts via CMS API. Step 3. It measures outcome, traffic, rankings, updates its model or prompt templates, and tries different headlines or meta descriptions. This loop repeats until the KPI improves or the agent hits guardrails. Mini case study. You can reference real-world examples like AutoGPT-style agents that orchestrate APIs or OpenAI DeepMind research on agents using self-play. In practice, teams combine simulation environments for safe exploration, reward models learned from human preference data, and strict sandboxing to reduce risk. You can't improve what you don't measure. Key metrics: objective KPIs, task-specific, sample efficiency, improvement per interaction, safety metrics, policy drift, unintended actions, calibration, confidence versus correctness, and robustness tests, distribution shift. Also set early stopping and rollback mechanisms in your deployment pipeline. Safety first. When agents can self-modify, guardrails are critical. Use techniques like reward constraints, adversarial testing, human-in-the-loop approval for high-impact actions, sandboxed execution, conservative exploration policies, and continuous auditing. Always define what constitutes unacceptable behavior and implement automated alarms and freeze switches. If you want to experiment, start small. Tools and libraries to check out. Orchestration frameworks, RL libraries, stable baselines 3, RL-lib, simulation environments, GIN, Unity, model fine-tuning toolkits, and monitoring solutions. I'll drop exact links in the description so you can follow along and reproduce demos safely. Quick best practice checklist. 1. Start with explicit, measurable goals. 2. Use simulated exploration before real-world actions. 3. Maintain human oversight for high-stakes actions. 4. Track drift and performance metrics. 5. Version your models and allow rollback. 6. Iteratively refine prompts and reward models. Small, validated steps beat big blind updates. Alright, if you enjoyed this breakdown, like the video and subscribe for more deep dives. Comment with questions or your experiments. I love reading what you build. If you want the demo code and resources, hit the description link. And if you'd like a follow-up deep dive into safe reward design or a live coding walkthrough, let me know below. To summarize, Agentic AI turns prompts into formal goals, decomposes tasks, plans and acts, observes outcomes, and updates using mechanisms like fine-tuning, RL, and meta-learning. The key is structured goals, robust measurement, and strong safety guardrails. Thanks for watching. See you in the next video.